Good day, everyone. I am Ma'am Michelle Chua of National High School, and I am going to discuss today about Newton's law of motions. The Newton's three laws of motions are law of inertia, law of acceleration, and law of interaction. Again, I am Ma'am Michelle Chua of National High School, your grade 8 science teacher for today. While most people know what Newton's law says, many people do not know what they mean or simply do not believe what they mean. Newton's laws of motion includes the following. First law. An object at rest will stay at rest, or an object in motion will stay in motion at constant velocity unless acted upon by an unbalanced force. So what does it mean? An object will remain on its original position unless there is an outside unbalanced force acting on it. Like for example, a stone that is situated on the top of a hill. That stone will stay there as long as there is no outside force acting on it. The second law states that force equals mass times acceleration. So this is the law of acceleration. This law of acceleration states where the mass is equal or the force is equal to the mass of an object times its acceleration. Then the third law states that for every action there is an equal and opposite reactions. As we go to our study for today, you are going to discover those three laws of motion. And you are going to discover also how these laws of motion is applied to our daily lives. First law of motion, law of inertia. It states that an object at rest will stay at rest and an object in motion will stay in motion at constant velocity unless acted upon by unbalanced force. So, one example of that is when you are riding on a jeep. When you ask the driver to stop and you are going to come up with on the jeepney or ride on that jeepney, the motion of the jeepney is ongoing and the driver will step on where for it to stop. Yes, it is on a brake. So if the driver step on the brake, the person inside the jeepney will suddenly move forward. While when you are already inside the jeepney and some other passenger asks for a ride to a rider or to a jeepney driver, you suddenly felt the forward motion when the jeepney driver stepped on a brake. Did you experience that, class? Yes. And while or when the jeepney is from the resting position, the object or the person inside that jeepney will move backward. So what does it mean? So the inertial state of the object inside a jeepney, which is the passenger, will remain at rest unless it is permitted by the driver to move, or the jeepney move forward or backward. So look at the picture. So inertia is tendency of an object to resist changes in its velocity, whether in motion or motionless. So try to look at the picture. There is a pumpkins. These pumpkins will not move unless acted on by an unbalanced force. So if that pumpkin stay on their original position, it will not be affected by the other thing. But when you remove one of those pumpkins in the pile of the pumpkins, the tendency of the inertial state of that pumpkins is to be disturbed, and that pumpkins will roll down, or it will be displaced on its position. Next, this is a picture, or look at the picture. So what did you see? So that is a picture of a golf ball standing on a tee stand. So once airborne, unless acted on by unbalanced force, gravity, which is the gravity in air, fluid, or friction, it would never stop. So again, if this golf ball was released or hit by a club, it will move forward or on the direction where the force is applied. Then, unless acted upon by unbalanced force, this golf ball will sit on the tee forever. So it will never move unless there is an outside force acted on it. So what are those outside force? So maybe that is a wind, gravitational force, or wave or movement. So this is the questions for you. Why then do we observe everyday objects in motion slowing down and becoming motionless, seemingly without an outside force? Again, the question is, why then do you observe everyday objects in motion slowing down and becoming motionless, seemingly without an outside force? So, if your answer is friction, so you're correct. So, it is a force where sometimes cannot see. So, that is a friction. So, what is friction? Objects on Earth, unlike the frictionless space the moon travels through, are under the influence of friction. So, what is this unbalanced force that acts on an object in motion? Yes, that is friction. So there are four main types of friction: sliding friction, rolling friction, fluid friction, which considered as air or liquid, then the static friction. So what is the difference between the four? So these four main frictions differs from one another. So like for example, a sliding friction. So one example of that written in our board or in our screen is ice skating. Have you seen an ice skating? Who among of you experienced an ice skating? Is it fun? Is it a fun work or activity? Yes, it is. But it is also hard if you cannot balance yourself on the skating, roller skating. Okay? So that when we said sliding friction, it is a friction between two objects that is smooth, and they are simply sliding, gliding with each other. Okay, so once example of that is your book. So if your book you try to slide your book on the floor, what do you think will happen? Okay, very good. That will slide, but at a certain point it will stop. Do you agree with me? Yes, it will stop. Because of what? Yes, because of gravitational force. Next example of friction is the rolling friction. One example of that is the bowling ball, or anything that is in circular or in circle shape. It is rolling. So it is, if it is not circle, would it roll? If it's a triangle, do you think it will roll? Yes, it's a no. Okay? Then the other example of friction is the friction or the liquid or the fluid friction. Sometimes it is called air friction. So air or water resistance. So one best example of it is the friction between the swimmer and the water inside a pool. So once a swimmer pull the water backward, the tendency of that swimmer is to move forward, because that is the friction. So they will swim on the water, and the water, they will be able to push themselves on the water. So that is the fluid friction. That is also happening when there is a certain time where the, what do you call that? The skydiver. So, have you experienced that? Maybe no. Sometimes we are afraid of the height. But some other people, especially on the other countries, they are fan of the, what do you call that? Skydiving. So, they will ride in an airplane, then go on a certain height, so maybe 1,000 or 100 feet from the ground, then they will jump. But they will not do that without the parachute. Okay, so that will save them to fall from the ground or to the ground. Have you imagined that? Okay, very good. So static friction. Initial friction when moving an object. So when we said static, that is the initial state or initial or the beginning position of an object. Okay, do you have any questions? So if you have a question, just key in your question on our chat box. We will proceed now to the next. Okay, so this one is an activity that I want you to try at home or with your parents. Slide a book across the table and watch it. Slide to a rest position. The book comes to a rest because of the presence of force, and that force being the force of friction, which brings the book to a rest position. In the absence of a force of friction, the book would continue to move or in motion with the same speed and direction forever, or at least to the end of the tabletop. But the book stopped at a certain point. Am I right? Yes, because that is because of, yes, very good. That is because of friction. Okay, let's see. Again, kindly observe. So, Newton's first law and U. So then, let this be U. Wear seatbelts. Because of inertia, the objects, including you, resist changes in their motion. So when the car going 80 km per hour, it stopped or is stopped by the brick wall, your body keeps moving at 80 km per hour. So this is usually happen when there is an accident. If the driver is not wearing a seatbelt, they will fly outside or they will hit the windshield of their car. Okay, next. Newton's second law of motion. So, what can you say about the formula? So, F is equals to M times A. So, what does an F means? Yes, it is a force. How about an M? Yes, it is a mass. And how about a letter A? Okay, very good. That is an acceleration. So, force or the net force of an object is equal to the product of its mass and acceleration, or simply the formula M is equals or F is equals to M times A. Or simply force is equals to mass times acceleration. So, and the second law of motion states that when a mass is in kilogram and the acceleration is in meter per second, the unit of force is in newtons. So 1 newton is equal to the force required to accelerate 1 kilogram of a mass, or 1 meter per second. So I have here a sample formula or a sample problem that I want you to analyze for you to understand the Newton's second law of motion. So the question is, how much force is needed to accelerate a 1,400 kilogram car 2 meters per second. So what are the first thing that you should do? First, you have to write the formula. So again, what is the formula? Okay, very good. Formula for force is equals to, or F is equals to mass times an acceleration. Then, after writing the formula, you have to fill in the numbers and units, or fill in the given numbers and units in our problem. So, as you observe to our problem, there are two numbers that is written there. 1,400 kilogram and 2 meters per second. So that 1,400 kilograms is a mass, while the 2 meter per second is the acceleration. So again, solve for the unknown. So you already have your given which is the mass and the acceleration. Now, what is missing? Very good. That is force. So, again, supplying the given to our formula, which is F is equals to M times A, or force is equals to mass times acceleration. So, the given mass is 1,400 kilogram times the given acceleration, which is 2 meters per second or 2 meters per second squared. So simply multiply the two given numbers and you will get the answer, 2,800 kilograms meter per second or simply 2,800 Newton. Now, I will give you 5 minutes to solve this problem on your notebook. Okay? So I will give you 5 minutes. And your timer starts now.